Okay, students, this is the gum problem from 3.3, and I'm just going to go over this. If you look on 3.3, it's problem number 8, and it's talking about somebody riding their bike over a piece of gum. So I'm just going to draw in here the wheel of the bike, and this is the center. It says that the diameter is 68, let's see here, 68 centimeters. So I'm just going to draw this, and this is our radius, which will be 34 centimeters. So what I like to do with this is I like to start plotting out the information given to get a better feel for what type of graph I'm going to be drawing. This is saying find a trig equation. It's not telling me which one, so that means we get to choose. So let's see. We have this gum that was ridden over, and it's going to go round and round and round. So the gum is going to get to a high point, come back down, get to a low point, go back around. So it's going from max to min to max to min. So this sounds like a sine cosine curve from what I'm looking at. We have, this will be our time in seconds, and this will be the height of the gum in centimeters. Okay, so if we're looking through here, let's see, we're talking about 1 second. So I'm going to put 1 second every 2 boxes. Let's do that for now. And then I'm also going to say the highest this gum gets is 68 centimeters. So I'm going to put this as 68. This is my 34 centimeters, and you can change it however you like. It's telling us that at 1.25, 1 1/4 seconds, the gum is at, let me make sure I'm reading this right, time t equals 1.25 seconds, it's at a maximum height above the ground. So I'm putting this point right here. I'm calling this my max height of gum, and I'm going to have the ordered pair at 1.25, rather, 1 1/4, comma, 68. Okay, so that's the highest the gum is. Then it says 1 whole second later. That's 2 1/4 seconds. It's at the lowest point. Well, the lowest point for this is going to be when it's touching the ground. Okay, so this takes, so half the period is 1 second, which means that the period is 2 seconds. That means it's going to come back up to a max. Let's write this in here. Hold on 1 second. Okay, so this is 4 seconds. And let's go ahead and put that full cycle in. That means at 3 1/4 seconds, we're back up to the highest point. So this is 3.25 seconds. We're back up to 68. Down here, this is 2.25 seconds. And we're at a height of 0. We're on the ground. So we can start drawing this in here. And I think, let's see. 1, 2, yeah, that's close. Probably a little further over there. 1, 2, 4. Okay, I think I'm okay here, actually. Okay, I'm just trying to make sure I'm in the middle where I'm supposed to be. And there, yeah, that's pretty good too, actually. Okay, so the graph is not perfect, but at least my points are where they should be. So this point right here, in between 2 1/4 and 3 1/4, is going to be 2.75 seconds at a height of 34. And this one here is going to be 1 3/4 seconds, rather, at a height of 34. So this is actually where that midline is, if we're thinking of our graph. So the whole thing we're supposed to do here is write an equation or function to represent this. My opinion is this, to me, is speaking cosine with no reflection. You absolutely can write this as a sine function. No matter what you choose, if you have it, if you have the correct parameter changes, both of us will have the exact same graph. So for this one, I'm going to go ahead and, I don't really want that. Let's do this. We'll do, let's see, h of t, so this is the height of the gum in seconds, is 34, that's my amplitude, cosine function. Now, we actually need to do this. PB equals 2 pi, and the period is 2 seconds. So 2b equals 2 pi. B is pi. So everyone, whether you have sine or cosine, you should have pi here as the b value. Now, where did I start this? I started right here at 1 1/4, and I ended that cycle at 2 1/4. So that means we're going to say t minus 1.25 seconds. That's going to shift us to the right, 1.25 seconds. And then we are going to have our midline up at 34. That's where that midline is drawn in the graph. So this is our function. Now again, you might have written this with sine. That's absolutely fine. You could write it with sine with a reflection, without a reflection. It's going to change your horizontal shift. But your b value, like I said, that b value will be the same. Okay. All right, so the next part of this is saying find the height of the gum when 15.6 seconds have passed. So let's take a look at this. The height at 15.6 seconds. So our job right now is to go ahead and just plug in 15.6 into our function and do the calculations. So the height at 15.6 seconds, when I go ahead and calculate this, we should get, let me make sure I have the right thing here. We're going to get 49.436, and this is in centimeters. So we're going to say at 15.6 seconds, the gum is at a height of 49.436 centimeters from the ground. Let's see, at this many seconds, the gum is at a height of this from the ground. Or maybe away from the ground. Let's try that. Above the ground. That's the preposition I want. Above the ground. Okay. Now, the last part of this, in my opinion, is probably the more complicated part. This is asking me to find the first and second time that the gum is at this height of actually 12 centimeters. Now, let's think about, if we look back to our graph, I'm going to use the highlighter here. Let's think about this. So halfway through is 17, so it's a little less than half. Oh, that is way too wide. Let's try to make that skinnier. See if that works. Okay, now if I do this, okay, let's try. Okay, so we're going to say that this is about 12 centimeters. Now let's see here. Let's go across. Do you see where it's hitting? Here and here. But that's not the first and second time. If we try to extend this graph, let's do it. Let's do the highlighter with this. We would say, so this is, we want one more second to the left. So we're going to go somewhere here. Let's see. We're going to go 1, 2, we'll go here and here. So if we keep going, and this should have been a little more like that probably, and this obviously then is going to keep going up, right? But look at, this is actually the first time it's hitting that height. So this is a little tricky. So let's go ahead and first solve and then see what value we get and then go back to the graph, okay? So let's go ahead here and we'll definitely pull it back to that graph to make sure we understand what's going on. So this is telling us, hey, we know the height. It's 12 centimeters. Our job is to solve for t. Okay, so we're going to use that original equation that we came up with. We'll subtract 34 from both sides. So we get negative 22 equals 34 cosine pi, whoopsies, that's supposed to be a t, minus 1.25. We divide both sides, wow, by 34. And then we'll take the inverse cosine of both sides, because that's how we're going to undo that. And then we're going to use the calculator, which remember, there's the domain has been restricted, right? So we gotta be real careful with these because the calculator is gonna give you an answer, but it's only gonna give you that restricted. So let's see here. So we have cosine inverse of negative 22 over 34. And that will be equal to pi times the quantity t minus 1.25. I'll divide both sides by pi. And I'm going to wait until the end to actually do the calculation so I don't lose a bunch of values. And then I'm going to end up adding 1.25 to both sides. And that will get us t isolated. So when you actually plug this in, the time that we're going to get for this is, let me make sure I have the right, 1.974. So that's the value you're going to get calculated. Now let's think about this. It's almost 2 seconds. So let's go back to our graph. Where is almost 2 seconds? That's about here. Okay, so let's say that's about the height of 12 centimeters. If you did this on Desmos or a graphing calculator, you'd obviously have more exact values. We need to find out, well, what the heck is this time over here? We can estimate it, but let's think about this. If we're going from 1.25 seconds, right? We're going from here to here. Well, how much space is that? Let's think about it. 1.25. So we're going to say, well, what is 1.974? Take away 1.25 seconds. Okay, so this is the time from the max to 12 centimeters. Okay, the time it takes the gum to travel from the max height to 12 centimeters. So when we go ahead and subtract this, we get 0.724 seconds. So what I would like to do is I would like to go in reverse, and I would like to subtract 0.724 from the max to go to the left. Okay, so this is the second time. So the second time gum at 12 centimeters is this. Okay, now the first time the gum is at 12 centimeters is going to be 1.25. Remember, this is the max, the time it takes to get to the max. That's where that one max is, right? Subtracting 0.724. And so that we're going to get, when we subtract, we're going to get 0.526 seconds. Now let's do a sanity check on our graph. Does it make sense that at about 0.5 seconds, about a half second, it would be in the same location? Now here's 0.5 seconds. So it's right, it's in the right ballpark. Again, I drew this by hand, so it's not going to be perfect, but it definitely looks like it makes sense. Now, again, we move the same spot to the left, and that's giving us that same height. That's what we're looking for. We want that same height. And if we went again, we would find it here. And then again to the right, and it would keep going, right, forever. Okay, as long as this person's riding their bike. So we would say the gum is at a height of 12 centimeters. First at 0.526 seconds, and then at 1.974 seconds. Now, it's not asking us every time. It said when are the first 2 times. But you want to make sure you don't get tricked on this and you find this guy here and then you go and try to find this next one, because this is actually not the first time. So that's where you really need to dig into the graph and understand what's happening, how long the period is, and what that cycle means. Okay, I will see you guys real soon.